Let's have a deep dive regarding the features of metamorphic rocks. So here you can see features of metamorphic rocks. So they are very hard. They're very hard, and they are harder than these parent rocks sometimes. Yes, they some in some cases they are harder than the igneous rocks as well. If there is an igneous rock, and if this igneous rock is subject to further metamorphism, so as a result of further metamorphism, hardness would certainly. Here you can see an example. Suppose we have a shell that is, you can say, one of the kind of rock, and when this shell is subjected to increasing temperature and increasing pressure, so that could be transformed in terms of slate. If there is a further action, or let's say further metamorphism, so there would be a what? Schist. If there is a further metamorphism, you would have a formation of gneiss. And if there is a further intense temperature, so we could have a blue schist. So that is what? That is the increasing metamorphic grade. Means if you move towards the more intense and pressure, so the characteristics of rocks would going to change significantly here in this way. So as per the intensity of temperature, as per the intensity of pressure, we would have a rock. Suppose if it is going to stop here, you would have it. Suppose the process will going to stop here, you will have a schist and let's say gneiss in this way. So these rocks, sedimentary metamorphic rocks, are actually hard. They are hard and denser than their parent rock. Their texture is actually crystalline. Yes, they have some sort of similarity with the igneous rocks. They have some sort of crystalline properties. They have a crystalline structure due to mineral recrystallization. Here there is a further, so as a result of temperature and intense heat, there will be a recrystallization. As a result of recrystallization, this metamorphic rocks will also have a crystal appearance structure. The structure is basically having some sort of characteristics which we are referring here as foliation. Here you can see. So now you will say this is what the having a similarity with that of layered wise arrangement. So but this is what the foil, you can say that here we have a layered and bending of non-foliated massives. This is the non-foliated. We could have so many non-foliated rocks, and these rocks would appear in terms of layered wise arrangement. Yes, but the characteristics will be different as that of sediment. Sedimentary are soft, but these rocks, these metamorphic rocks, are very hard in terms of their structural appearance. So here we will have what? Foliated structure, which is similar to the layered wise arrangement. Again, how it is different from sedimentary rocks? It is different from sedimentary rocks in this way that sedimentary rocks is loose, while metamorphic rocks are very much harder. Sometimes they are harder than the igneous rock itself. Now, if we see these sedimentary rocks, so here we have a minerals and new minerals, old minerals. They would be further refined, and rearrangement of minerals could also be found, especially in, sedimentary to metamorphism, or ultimately you can say metamorphic. So these are some of the features specifically with. Moving ahead, if you see the remains of fossils, here remains of fossils are not. Why? Because suppose there is a sedimentary rock, and in this sedimentary rocks we have a layered wise arrangement, and in this layered wise arrangement we could have some, and if this, and in these layers, if there is a compaction, if there is a layering, if there is a cementation, if there is a lithification, temperature, there is a pressure, what would happen? That at the high temperature, this organism, or let's say this living trace, or let's say fossil trace which is there, now this will going to evaporate. Okay, because at that much high temperature, this fossil or this carbon material which is there, that cannot sustain. So there will be a vaporization. And when there is a vaporization, so what we can say that yes, we have a pure strata of rocks which will remain left. So usually these metamorphic rocks are, they do not have a occurrence, or they do not have a trace of fossils. Okay? It's because like the process which is responsible for their formation requires a lots of temperature and pressure at which fossils, the living trace of life, or let's say dead material, which is dead organic material which is there, that cannot able to sustain at that high temperature. As a result of this, they may not have a finding of fossils, but sometimes you may see, if the metamorphism is not taking place completely, if there is a partial metamorphism, so here in that case even you can see that some of the organic, some of the fossils remains specifically. But at a large extent, if you see the purest form of metamorphic rock, you may not see the any trace, or let's say any fossil. If there is a partial metamorphism, then yes, okay. So fossils are rarely preserved and they are destroyed by the heat. If you see the appearance of these sedimentary rocks, the appearance of sedimentary rock is what, like they often exhibit, they often shows the characteristic features of bending. It's just like that foliation. So bending is there, then we could have a sheen or crystalline growth would be there, especially in these metamorphic rocks. In metamorphic rocks, we have a high resistance. They are more resistant to erosion and weathering because the gap in between the atoms and molecules very less, and it is because of that it is not, or let's say it is rarely cause some sort of exogenetic influence. As a result of less exogen, what we can say, the erosion and weathering would not that much dominant, which is actually dominant in igneous, or let's say. So these are characteristics